All right, so first of all, you are getting this into your notes, but notice some notation here. Y equals f of x plus v. Remember, f of x represents an original function. So in the case of these examples down below, here f of x was the absolute value of x. Here f of x was x squared. They're just different function types. So the idea here is that if we take whatever our original function is, if we add a number to it at the end, and v is just going to be a number, it's going to move it up v units. Now, notice though, if it is negative, if this was a minus, let's say it's minus 3. Notice if it's minus, then it shifts it down. So that number hanging on the end, it always moves it up or down. Why do we use v? V stands for vertical. So it's a way to remember it's a vertical shift. Using these notes, we're going to be able to now graph a number of different things that before we could graph them, but now we can actually graph them based on the equation. We're going to start by taking a look at this as an example. Y equals the absolute value of x minus 4. Please start by writing this equation above your first graphing grid. So the first thing we're going to do with this one is we're going to describe the transformations. Because in the past, I've given you these equations and I've given you the transformations written out in words. So by writing out the transformations first, we can bridge that gap. We can see, oh, okay, this is the same thing as this. So the transformations here. The minus 4 hanging on the end. That minus 4 hanging on the end, that means v is negative 4. That means it's going to shift it down 4. And so what that tells us then is that this is going to be the same as our regular old absolute value of x graph shifted down 4, which actually is something you're well familiar with. So let's go ahead and actually start making that graph. That means my first point is down at negative 4. Then we say, okay, this is absolute value. So now that I know where it was moved to, since it's absolute value, I know the shape is a V shape. And so that tells me that it's going to be going over 1 and up 1 on both sides of that. And remember the V shape that's absolute value? It is going straight on both sides. So it's going up 1 over 1, up 1 over 1, up 1 over 1, all the way out to the edge of the graphing grid. Go ahead and put in all those dots. And then draw in the graph. Since this is straight, feel free, of course, to use a ruler. In fact, I'd even encourage you to use a ruler. The only difference between this and what we were doing in our very first unit is that now instead of me just giving you the words shift down 4, I can actually show it to you in the equation where we have the absolute value of x and then the minus 4 hanging on the end to tell us that that's what's shifting it. We can, of course, apply it to many other different types of equations, and so that's what we're going to do. Here's our second one that we're going to practice together. Please write this equation, y equals x plus 5, above your second graphing grid. And just like with the previous one, I'm going to start by describing the transformations. So if I have a plus 5 hanging on the end like that, what is that as a transformation? Very good, yep. We're starting to see it. It is a shift up 5. Because it's positive, that's why it's going up instead of down. And one of the trends you'll see going forward is every time we add or subtract, it's always a shift of some sort. All right, so once we know that it's shifted up 5, we can go ahead and plot that first point. So it shifted up 5 for our first point. But then from there, what's the shape of this graph going to be? Linear, absolutely, very nice. Which means it is going to be a line going up 1 over 1. And it's a line, so it's not going up and to the left, it's going down and to the left. Because remember, it's a straight line, not a V shape. So we put in those points to be accurate, and then use your ruler, draw in the straight line that connects them, please. Now let's apply it to this equation, y equals x squared minus 6. So again, Above your next graphing grid, please write the equation, y equals x squared minus 6. And then write out the transformation as well, because I think you got that part down by now. All right, so let's check on the transformation here. The minus 6. What is the minus 6 doing to our graph? It is shifting it, yep, down 6. I don't really need to say shifting. We can just say shift down 6. All right. So then, that tells me where my first point is. So it's going to be down 6. But now we have to remember what the shape of the graph is. The shape of the graph is determined by this part here. In this case, I'm seeing, oh, it's an x squared. Since it's an x squared, it is a parabola. Remember, that's the fancy math name for that U-shaped graph. So our first points are over 1 and up 1 on both sides. But then, unlike some of the other ones we have, we do not go over 1, up 1 again. Instead, we're going to go over 2 and up 4. And if you don't remember why it's over 2 up 4, it's because this is x squared. If I go over 2, I go up 2 squared, and 2 squared is 4. So similarly, if I go over 3, 3 squared is 9. So it would be over 3 and up 9 for the next point. And again, remember, when I count those out, like over 3 up 9, I'm counting from the vertex. That is that original point that we plotted. We're always counting from that point. All right, let's see if we can fit another point on. We always got to plot every point that fits. So what about over 4? If I go over 4, how far up should I go?
16.
16, yes, because 4 squared is 16. That does fit. Barely, but does fit on our little 10 to 10 graphing grid. So plot that point as well, and then go ahead and draw the curve that goes through those points. Okay, next graphing grid. Write this equation, y equals 2 to the power of x minus 1. And then again, describe the transformations. And then if you're feeling comfortable making the graph, go ahead and make the graph from there. If not, describe the transformations, then hold tight, and we'll walk through it together. So describing the transformations for this one. The minus 1 hanging on the end, that is a shift down 1. And remember, it's down because it's a minus 1. All right, from there, we now need to make our graph. But remember, this is 2 to the x. This one's a little bit different. My first point is not going to be down at negative 1. That's not actually a point on this graph. Instead, this is the one where it's going to level out along that line that used to be at 0. That line was moved down. So that line is now down at negative 1. Draw that dotted line in first when you make this graph. It makes it so much easier. Because now from there, I can pretty much ignore the x-axis. What I'm really looking at here is that dotted line. And I know my first point starts up 1 from there. So I'm going to put my first point up 1 from that dotted line. In this case, that happens to be at the origin. So then, making the graph from there. Of course, you can always consult your notes if you're a little rusty on this, but what do we need to do? We go up 1, then we go up 2, then we go up 4, then we go up 8. The whole idea here is if you're graphing 2 to the x, basically it doubles the height every time you go over 1. So it goes 1, 2, 4, 8, then 16 if it had fit, and so on. Going to the left, remember this is the one where it goes to a half, and then to a quarter, and so on and so forth. And so then, draw in the curve that goes through those points. Check to make sure that that is the graph that you ended up with. And again, if you didn't include the dotted line, go back and draw it in as a reminder to yourself, because that dotted line makes a world of difference when doing these graphs. Last one that we're going to do together here, y equals the square root of x plus 4. Write down the equation, describe the transformations, and do the graph. You should be able to do the whole thing start to finish this time. All right, so first up, you describe the transformations. In this case, there is one transformation. It is a shift up 4. And it's shifting up 4 because that plus 4. Plus is going to be up, minus is always going to be down. And again, make sure you kept that square root only over the x when you wrote it down. If you extended it out to be also over the 4, it would mean something different. And we aren't going to get into that for a little while yet. All right, now we go ahead and make our graph. When making this graph, yes, this one actually does start at the up 4. So that's our first point that we plot, is 4 on the y-axis. And then from there, this is square root, so whatever I go over, I square root it and go up that amount. So square root of 1 is 1. Over 1, up 1. How many of them start with over 1, up 1, right? Question is, though, what happens from there? Because in this case, if I go from that first point over 2, I don't know the square root of 2. That's why we don't do that. Instead, I want to go over 4, because the square root of 4 is 2. So that, then, is a point that I can actually plot. So over 4 and up 2. And then, again, I got to figure out, okay, next time I go over, I need another number I can take the square root of. The next number I can take the square root of is 9. And the square root of 9 is 3. So we go over 9, up 3 for our next point. And we aren't going to fit anything else past that because the bell rings. Because we're at the edge of the graphing grid there. So then go ahead and draw the curve in using those points. One little reminder about that curve. Please remember that our starting point with square root truly is the starting point. There's nothing below it, and there's nothing to the left of it because you cannot take the square root of a negative. So there's nothing to the left or below of this point that's at 4 in this problem.